x, y equals 0, and x equals 3, rotated around the x-axis. First, we have to rotate the region around the x-axis, like so. This problem uses the disk method. The disk formula is volume equals pi times the integral from b to a, big R, squared dx. So big R is the radius of the figure as it is changing. For this problem, we have to find the volume of the region enclosed by y equals 2x, y equals 0, and x equals 3, rotated around the x-axis. First, we have to rotate the region around the x-axis, like so. This problem uses the disk method. The disk formula is volume equals pi times the integral from b to a, big R, squared dx. So big R is the radius of the figure as it is changing. In this problem, R happens to be 2x because the radius is increasing by 2x each time. So, we plug in 2x for big R. Volume equals pi times the integral from 3 to 0 times 2x squared dx. Okay. Which means that the volume is pi times the integral of 3 to 0 of 4x squared dx. Okay. The integral of 4x squared is 4 over 3x to the third. So now we solve for the volume, f of 3 minus f of 0. Okay, f of 3 is 4 over 3 times 36. Okay, just kidding. F of 3 is 4 over 3 times 27 minus 0. So f of 3 is 4 times 9, which is 36, times the pi. We bring down the pi from up here, so volume is 36 pi. 36 pi. Okay, so this time we have to find the volume of the region enclosing y equals 2x, y equals 0, and x equals 3, but rotated around the line y equals 8. So this is a line over here. I already drew the region. And the line y equals 8 is right over here. So the first thing you have to do is rotate it on this side. So over here at 10 is where our other triangle is going to start. Like this. So this one has actually a hole over here and one at the top, which means we're using big R and little r again. So as last time, we're using the washer method, which is volume equals pi, the integral of from b to a, big R squared minus little r squared. Big R is going to be, just as last time, the area from the line that we're rotating the whole region around to the top, or the outside. So big R is a set line, which is a set area actually. So it's 8, since it starts from 0, goes up to 8. Little r is the region from the center to this inside, just this part. Right here. So little r is 8 minus 2x, since you are subtracting this region from 8 to find this region right here. Okay, so then you plug in big R and little r to the equation. So you get pi times the integral from 3 to 0. Big R is 8, so 64 minus 8 minus 2x squared, which is 64 minus 64 minus 32x plus 4x squared, which crosses out 64, and you end up with 32x minus 4x squared. So then you have to find the integral from 3 to 0. So the integral of this would be 32x squared over 2 minus 4x cubed over 3. And then this crosses out, so you get 16x squared minus 4 over 3x cubed. Okay, so now that you have the integral, you find from 3 to 0. So f of 3 is 16 times 9 minus 4 over 3 times x cubed, which is 27. Okay, so this gives you 144 minus, cross these out, gives you 9. 4 times 9, which is 36, which gives you 108. And then you bring down the pi, last time, that gives you 108 pi as your ln. So 108 pi. Okay. For this question, we have to find the volume of the solid whose base is bounded by the circle x squared plus y squared equals 25, which is this circle, with the indicate cross-section taken perpendicular to the x-axis, which basically means that our base is going to be this circle, and what we have to find is squares perpendicular to the x-axis. over here, like this. How you find the volume of this is with this formula. V equals the integral from B to A, the area, and then dx. Okay. So first we have to find the area. The area for a square. So it's a regular square. So the area of a square is area equals a side square. So one of these sides for the square is going to be y and y. This entire side is going to be 2y. So our area for a square is 2y squared, which is 4y squared. So as you can see, our answer is in terms of y, and we can't have that, so we have to turn it into x. Okay, so from the equation we had before, x squared plus y squared equals 25. We subtract x squared minus x squared on both sides, and you're left with y squared equals 25 minus x squared. So now we have y squared, and we can turn it into terms of x. 25 minus x squared. Oh, actually not squared because it's y squared already. So going back to the original equation, we're going to have to change it a little bit because this graph of this circle goes from -5 to 5, and we don't want it to cross itself out, so we have to multiply the integral by 2. And then the area is 4 times 25 minus x squared. So that would lead to integral of 100 minus 4x squared. Okay. So the integral of that would be 100x minus 4/3 x cubed. Okay. And then we find f of b minus f of a. Okay, so f of b is equal to f of 5. So that is 100 times 5 minus 4/3, 5 cubed. So f of b minus f of a is f of 5 minus f of 0. So f of 5 is 100 times 5 minus 4/3 times 5 cubed, which is 500, minus 4/3 times 125. So this is 500 minus 500 divided by 3. This is the same thing as 1500 minus 500/3, which is 1000 divided by 3. And now we bring this 2 all the way across over here and multiply it. This makes our answer 2000 divided by 3 units cubed.